Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 29, Sprite Rotation. In this part of the video series, we're adding features onto the original Starfish Collector game that we created, working towards Starfish Collector 2.0. We've previously added solid obstacles to our game. In this and the next few videos, we'll turn our attention to some graphical improvements. For example, you might have noticed that no matter how you move the turtle around the screen, the turtle was always facing in one direction. So in this video, we will address that problem. We'll learn how to rotate sprites when they're drawn to the canvas, and we'll also add some angle-related functionality. Now by that, I specifically mean that we'll add an angle parameter to the sprites and some related methods. In addition to using that angle parameter when we draw sprites, we might want to set the angle, we might want to rotate by a certain amount, and in addition, it might be simpler to move in diagonal directions, for example, if we have a move at angle function. And finally, for even more simplicity and ease of use, we'll create a move forward function, which will move a character or a sprite a certain distance, depending on what angle they're currently facing. And so these are going to be the goals for this video. So first, let's open up our development environment. And let's go to the Sprite class and make some additions. All right, so a lot of good stuff in this class. So in addition to position, let's also add an angle. I'll add some comments to this later on. So we should also specify if we're going to be using degrees or radians for angle measure. All the mathematical functions in Java require radians as input, but for ease of use for us and other developers which might want to use this library, let's specify that angle is measured in degrees. And we'll do some conversion when we need to. All right, first let's go to the constructor, and when we begin the game, we will assume that the angle is set to 0. And when we say angle, as we talked about vectors before, angle measures the angle of a point between like a vector and the x-axis, right? It's going to be measuring this angle right here. By default, the angle of 0 degrees will indicate that a sprite is facing to the right along the positive x-axis. Okay, next let's add some more methods here. So for example, we have set position. Let's also add a set angle method. So public void set angle to some double A. And that's really just angle equals A. In addition, we might want to rotate by some amount. So let's add a public void rotate by. And this will be some double, not sure, maybe dA. And this will say angle plus equals dA. So increasing the rotation by some amount. And just to keep our code kind of parallel and well organized, I feel like if we have a rotate by method, we should have a move by method that adjusts the position as well. I've been thinking about that for a while, but now seems like the right time to add it in. So move by. This way we don't have to access the position directly. So double dx and double dy. So we'll say position.addValues, dx and dy. And again, just to parallel, if we're going to have a rotate by, let's have a move by function as well. All right, and if we have move by, it now makes even more sense and fits in nicely to create a move at angle function. Let's write public void move at angle, and this will take in two parameters, one representing a distance, and the other representing an angle. All right, so in order to figure out how this works, you might need to go back and maybe review some of the math when we talked about vectors. I don't want to repeat that here, but the idea is we can use right triangle trigonometry to figure out how much we need to add to each of the components of our position vector. Right, so in particular, I'll say, let's write a double called dx, and let's say that's equal to this distance times math.cosine times, well, I need the angle, and I need that in radians. So what I'll do here, so I know I wrote a capital A. I'm going to define A, capital A, to be math.2radians, whatever that angle little a is. So again, this angle A is in degrees. It's in degrees. Now again, I'll put more formal comments in this later on, but convert that angle to radians and call that capital A, and use that in the mathematical functions to calculate how much we want to move along the x direction, and similarly, to calculate how much we want to use to move in the y direction, we use the sine function. And once we have those two values, dx and dy, let's move by dx and dy. And again, this might make some of the code easier to read. We just do have to remember that the angle of 0 degrees points to the right, and also, since the positive y-axis points downwards in computer graphics, an angle of 90 would move a character down the screen. So just something to keep in mind. Finally, let's write public void. We also said we'd do a move forward function. In this case, we only need to specify the distance. And the idea for move forward is we'll just move the sprite forward at whatever angle it is currently facing. Right, this would be good for a game like Asteroid, say, where whenever you apply the thrusters on your rocket ship, you're going to move forward in the angle that you're facing. So this will probably become useful in later games, but now is the right time to add it, even if we don't use it right away. So in this case, we just need to say move at angle. We're using this distance value and whatever the currently stored angle in the sprite is. Right, those are the angle-related methods we wanted to take into account. Next, we need to update the draw function. And so we draw, taking that angle into account. And there's a few complexities here we'll have to talk about. Right, so what we're going to do is first calculate the cosine and sine of the angle, converting it to radians first. So once again, I'll say double A equals math.2radians, whatever the current angle is. And then I'll use that to calculate two things, which I'll write as cos A and sine A. This will just make the code which is coming up a little bit easier to read. All right, now what we need to do here is change the way set transform works. Now earlier we mentioned that this applies rotation and translation to an image. Specifically, we translate it to this position, but these other values here, it's not really quite clear what they do. And what happens is these values are multiplied, the current position coordinates are multiplied by these values, and if you put the right constants in here, then that will cause your sprite to be rotated when it's drawn onto the canvas. Now, this is a little bit of a tricky concept. This has to do with something called matrix algebra, and specifically something called a rotation matrix. It's a certain set of numbers you need to multiply to create that transformation. But since this isn't a math class, I'm just going to enter in the numbers here. But effectively, this represents the first column of a matrix, which will be multiplied by the current position. And then the next two values represent the second column of a rotation matrix, which is used to adjust the position. And these values they'll rotate the sprite for us. Now, there's one other thing that we're going to need to take into account. What is the point of rotation of a sprite? And so, for instance, do we want to rotate a sprite around one of its corners? Do we want to rotate a sprite around its center? Right? We need kind of a pivot point to be identified in the sprite. Now, by default, when we apply a transform to the canvas, this rotation is around the point 0, 0. By default, rotation happens around the origin of the canvas. The way that the image is getting drawn right now, right, the draw image function is taking part of our image texture and it's mapping it to this rectangle. Right, so this sprite by default is drawn so that its top left corner aligns with the top left corner of the canvas. Right, which means the top right corner, since it's being aligned to 0, 0, this would cause sprites to rotate around their top right corner, which would look a little bit strange. So we'll actually have to change this code, but I won't change it quite yet because I do want you to see what happens if we leave the code as is. So we're not done here yet, but I promise you we will come back to this in a moment. That being said, let's go ahead and let's go to Starfish Collector. And what I'd like to do now, just to illustrate the rotation to make sure that that works, right? Maybe we want to rotate the turtle when we press a certain key. And this is just a temporary bit of code for illustrative purposes. Let's say is key pressed. Let's use the R key for rotate. Let's say turtle dot rotate by. And since this is in degrees, we can think of this as degrees per frame, not degrees per second, because this function will be called 60 times per second. I'm going to put in what looks like a very small number here, but again, this value, in this case I've written that as 2, will be rotating by 2 degrees 60 times per second. Right? So this would amount to a rotation of, well, 120 degrees per second. So let's go ahead and save this and give this a run. And we're just checking that the rotation functionality works. Right, so some code is compiling. Right, here's our turtle. And the turtle can still move around, but if I press the R button to rotate, do you see how it's rotating around this point where the cursor is highlighted? And again, that's because the turtle, if there's no translation taken into account, the turtle is drawn here, and canvas rotation happens around this point. So what we actually need to do to get the turtle to rotate around its center, and rotation also is not taken into account with boundary detection, to get the turtle to rotate around its center, we actually need to change that transform bit of code so that the center of the turtle is aligned with the origin of our canvas. And then the turtle will spin correctly. So I'm going to go ahead and go back to the sprite code. And so instead of drawing the turtle along this location, we're going to back it up by half the width and half the height. So minus this dot width over 2 and this dot height over 2. And negative in both cases. And so again, this will shift it to be aligned, so the center of the turtle, or the center of any sprite, is aligned with the origin of the canvas, and that'll enable it to rotate around its center. Let's go ahead and draw that one more time, or rather, run that one more time, so we can see how draw works. All right. Now, in this case, right, I can move my turtle around, and rotation works perfectly. But do you notice there's something else which has changed? Right? Because of the way we initially shift the turtle, or we shift every sprite really, so that its center is aligned with 0, 0, that's going to cause everything to be shifted by half its width and half its height. In order to make rotation work the way we want it to, rotating around the center of an object, we now have to realize that the x and y coordinates of an object are now its center. Right, so that's just something to think about in the Sprite class. Right, it doesn't really mean we have to change any of this code, but it does mean when we create our game, right, where do we want to position the center of these objects? Right, so for instance, when we first created the water, we didn't set its position, right, because by default x and y are both set to 0. But in this case, since x and y are now being interpreted as the center of a sprite, I do want to say water.setPosition to, in this case, the middle of the screen. Since the window size is 800 by 600, I'll set its position to 400, 300. This also has an added advantage that it makes it easy to center things on the screen. For example, that win message that we had, you might remember we added that down here. I was kind of guessing at these coordinates in the hopes that it would be roughly centered on the screen, but now we can perfectly center it. Right? Set its position, the center of win message, to be the center of the screen. Right, and that'll make some code a little bit easier. Now if we go ahead and run Starfish Collector, we should see that the water is placed at the correct position again. And so that's great. And everything like collision still works perfectly fine. One thing we have to keep in mind though, like I've got rotation set up here, but yeah, that's not a perfect solution, right? Because the turtle is not facing the direction it's going necessarily. So that'll be the last addition we make to our code. So in the Starfish Collector class, in the update method, we had added this R for testing, and that was fun, but that's not really necessary in our final version of the game. Still would like to use the up and down values. Sorry, I'd still like to use the up, down, left, right control system, but I'd also like to rotate the turtle to match that. So in each one of these cases, right, instead of doing this, instead of saying turtle position add values, let's say turtle, let's do turtle.moveBy. Let's use that new function. I like it, it's already shorter. But also, if we're pressing right, let's also say turtle.setAngle to be 0 degrees. In other words, the turtle will be facing to the right. And I'd like to do something similar for each one of these cases. And so I'll replace the code in each case with a move by and a set angle. And let's see, moving to the left, that's moving by -2. Facing to the left is 180 degrees. Going up, that's moving by -2 along the y-axis. That angle will be 270 degrees. Finally, moving down, we want to increase the y value, and we'll set the angle to 90 degrees. All right, let's give that a save and a run. If everything goes according to plan, the turtle should now be looking where it's going. So here we go. I can go to the right. Now I can go down. Hey, look at that. That turtle's paying attention. Of course, there is a problem when you go at a diagonal. If you're holding 2 arrow keys at once, right, it's going to, one of those keys will take precedence, the one which occurs lower down in that list of input is key pressed. But there you go. The game just got a little bit better. The turtle can now look around the screen and watch where it's going, which is good advice for all of us. All right. So that's how we add angles and rotation functionality to our program. In the next video, we'll learn how to reflect sprites on the x-axis and the y-axis, which we call mirroring and flipping. We'll save that for the next video. Thanks for watching.